This video is about application of derivatives. Kinematics. Let's talk about terms used for kinematics: displacement, velocity, and acceleration functions. If a particle P moves in a straight line and its position is given by the displacement function s of t, t greater than equal to 0, then the velocity of P at times t is given by v of t equals s prime of t. In other words, velocity is the function of the derivative of displacement. The acceleration of P at time t is given by a of t equals v prime of t equals s double prime of t. In other words, acceleration is the first derivative of velocity. It's the second derivative of displacement. S of 0, v of 0, and a of 0 give us the position, velocity, and acceleration of the particle at time t equals 0. And these are called the initial conditions. This diagram shows the relationship between displacement, velocity, and acceleration. When we differentiate displacement, we get the velocity. When we differentiate velocity, we got acceleration. Let's talk about signs of s of t, means displacement. There is a origin position, which means s of t equals 0. When s of t is positive, means this P is located to the right of the origin. When the s of t less than 0 means the P is located to the left of the origin. For example, if this is the origin, which means s of t equals 0. At t equals t1, then we have s of t1, it will be greater than 0, because this position is on the right side of the origin. When we have this t2, so we have s of t2 is less than 0. In other words, when we say s of 2 equals -7, how to draw the diagram for that? This is the origin. And from the origin to the left, 7 units. This is 7. To the left side of the origin. In other words, this position will be s of 2. Now let's talk about signs of v of t. V stands for velocity. Velocity equals the first derivative of s of t, which means s prime of t. When v of t equals 0, means the particle is instantaneously at rest. V of t is positive, means the particle is moving to the right. Less than 0 means the particle is moving to the left. The diagram for this v of t equals 0. That means its velocity of t equals 0. That means at rest. If it's a positive, for example, like here's T1, we have v of t1 greater than 0, means moving to the right. When we have t2, v of t2, if it's less than 0, then means the particle is moving to the left. When v of t equals to 0, the particle will reverse the direction. And also, when v of t equals 0, it could be maximum or minimum of displacement. For example, if I have v of t equals to 7, which means the particle is moving to the right at a speed of 7. Now let's talk about signs of a of t. A stands for the acceleration. When a of t equals 0, means the velocity may be maximum or minimum or possibly constant. Because a of t equals v prime of t, it equals the second derivative of s of t. So when a of t equals 0, this go to the stationary point, means maximum, minimum, or constant number. When a of t is positive, means the velocity is increasing. When a of t less than 0, means the velocity is decreasing. So let's draw the sign diagram. This point means a of t equal to 0. If at t1 we have a of t1 greater than 0, this means the velocity is increasing. And for this point, it's a t2. A sub t2 if it's less than 0, which means the velocity of t2 is decreasing. And remember, when a of t equal to 0, means the maximum, minimum of velocity, or the velocity is a constant. Here's the very useful table you need to know. Initial conditions means t equals 0. At the origin means your displacement equal to 0. Stationary point means the velocity equal to 0. Reverse still means the velocity equal to 0. Maximum and minimum of displacement still means the velocity equals to 0. Constant velocity means the acceleration equal to 0. Maximum or minimum velocity means the acceleration is equal to 0. For reverse, when a particle reverses direction, its velocity must change sign. This corresponds to a local maximum or local minimum distance from the origin. We need a sign diagram of A to determine if the velocity of a point is local maximum or minimum. Because when you decide the velocity is a minimum or maximum, you have to use the acceleration to decide its concave up or concave down, so that you decide its a maximum or minimum for this velocity. Now let's talk about speed. Speed is a scalar quantity which has a size but no sign. Speed cannot be negative. The speed at any instant is the magnitude of the objective's velocity. If s of t represents the speed, then we write s equals absolute value of v. We use a capital S of t stand for the speed. But for the displacement, we use lowercase s of t. To determine when the speed s of t of an objective p with the displacement s of t is increasing or decreasing, we need to employ a sign test. If the signs of velocity and acceleration are the same, then the speed of p is increasing. When the signs of velocity and acceleration are opposite, the speed is decreasing. So in what situation the speed and velocity are increasing? When velocity and acceleration have the same sign, then the speed is increasing. When the acceleration is positive, which means the velocity is increasing. When velocity and acceleration have opposite sign, then the speed is decreasing. When acceleration is negative, velocity is decreasing. In other words, the velocity depends on the acceleration only. Speed depends on velocity and acceleration. Let's go to guided practice 1. A particle moves in a straight line with a displacement function given this. Centimeters where t is in seconds, t greater than or equal to 0. Find the velocity and acceleration function for the particle motion and draw sign diagram for each of them. So we have velocity equals derivative of displacement. You will get the 12 minus 6t squared. For acceleration equals derivative of velocity equals negative 12t. For the sign diagram, we have velocity. We need to figure out the roots for this. So we have 12 minus 6t squared equal to 0. Isolate the t squared on one side. We got the 6t squared equals 12. So we have t equals square root of 2. It's not negative square root of 2 because t greater than equal to 0. Therefore, we have 0 here. This one is a square root of 2. Then we choose a number 2. We plug in. You will get the negative. Then this is a single factor, so we change the sign. This part is a positive. Let's go to a of t. Draw the sign diagram. The root is a 0. So we choose a number like 1. This is a negative. So this will be the sign diagram for acceleration. Remember, t is greater than or equal to 0. So you have to put the 0 here. B. Find the initial conditions and interpret its meaning. As of 0, we plug in 12, 0 minus 2, 0 to the third power minus 1 equals negative 1. And we have v of 0 equals 12 minus 6, 0 equals 12. A of 0 equals negative 12, 0 equals to 0. For s of 0 equals negative 1 means P is located 1 centimeter to the left side of the origin. For v of 0 equals 12, P is moving to the right at a speed of 12 centimeters per second. Look at the C. Describe the motion of the particle at t equals 1 second. Motion means velocity. So we plug in 1 to the velocity function here. You have 12 minus 6 times 1 equals to 6. Therefore, the particle at t equals 1 second is moving to the right at 6 centimeter per second. Let's go to D. Find the time and the positions when the particle changes its direction. Change the direction when velocity equal to 0. 12 minus 6t squared equal to 0. We already solved this equation when we answer question A. We got the t equals square root of 2. Since we need to answer the position, you have to plug square root of 2 to the displacement function. Therefore, we got the 12 times square root of 2 minus 2 times square root of 2 to the third power minus 1. You will get 12 square root of 2 minus, for square root of 2 to the third power, you can do square root of 2 third power equals square root of 2 squared times the square root of 2. Therefore, you have 2 square root of 2. 2 square root of 2, then multiply by 2, you get the 4 square root of 2 minus 1. So you have 8 square root of 2 minus 1. The position will be 8 square root of 2 minus 1 centimeter to the right side of the origin. For E, draw a motion of the particle for the particle. Let's talk about the S of T. This will be the origin. When T equals 0, it's located here. This is 1 centimeters. Then it's moving to the right until they go to, here's T equals square root of 2. Then reverse the direction, go back. This will be the motion of the particle. Now let's go to F. At what times is the particle's speed increasing and velocity increasing? Speed increasing, you have to make sure velocity and acceleration has the same sign. Let's check the sign diagram for velocity and acceleration. When t greater than square root of 2, then the speed is increasing because they have the same sign. For velocity increasing, you have to make sure this acceleration greater than 0. Look at the sign diagram for acceleration. no time the acceleration is positive. So this one is none. Velocity is never increasing. What's the total distance traveled in the time from t equals 0 to t equals 2 seconds? For this question, we have to use this motion diagram. Let's draw over here. So we have, this is the origin. This is a t equals 0. Here's a 1 centimeter. Then go to t equals the square root of 2. We have 8 square root of 2 minus 1. Then we get back. We're looking for the distance at t equals 2 seconds. How far the particle traveled. First of all, we need to figure out s of 2 equals so that we can decide the location at t equals 2. So 12 times 2 minus 3 times 2 to the third power minus 1. You will get negative 1. In other words, this is a t equals 2. Go back here again. Therefore, how far they traveled from this very beginning, go here. Then basically go back again. So the distance the particle traveled equals 1 plus 8 square root of 2 minus 1. Then multiply by 2. You will get 16 square root of 2 centimeters. To guided practice 2. In this question, distance is in centimeters, time is in seconds. Particle A is moving along a straight line such that its displacement from a point P after t seconds is given by this. Find the initial displacement of a particle A from point P. In other words, the origin is P. So this is P. This is P. Here's P. The initial displacement, we just plug 0 to the displacement function. You will get the 15 minus 0 minus 6 times 0 to the third power. E, negative 0.8 times 0. You will get 15. So the initial displacement equals 15. Find the value of t when particle A first reaches point P. You need to set up s of t equal to 0. I use graphing calculator. Put the y1, this is the original function. I set up the window like this because the t is given between 0 to 25. For the y, I just assume it's between negative 20, 20. Then you can change later on after you graph the function. So I'm looking for the 0. They give to me the x equals 2.47 seconds. Therefore, the t equals 2.47 seconds. When you put into a calculator, every variable change into this x. Let's go to C. Find the value of t when the particle A first change its direction. First change its direction, that's velocity equal to 0. So basically, you're looking for this point, the minimum points. We go to graphing calculator. You will get the minimum point, that's x equals 4.08. So t equals 4.08 seconds. The last question, find the total distance traveled by the particle A in the first 3 seconds. You have to draw the motion diagram. The orange we call this P. So when t equals to 0, then the displacement equals 15. That's over here. This is a t equals to 0. Then according to the given graph, we could say it's moving to the origin. So it's going until that is when t equals 4.08, they stop. Then they will go back. First of all, we need to figure out when t equals 4.08, what s equals. Put into calculator, we got the s of 4.08 equals negative 4.66. When t equals 3, the displacement will be negative 2.70. We can label on this motion diagram. This is a 15. And here, the distance will be 4.66. And t equals 3, s equals negative 2.70. So it's on the left side of this P. This point will be t equals 3. This distance will be 2.70. Therefore, the total distance equals from 0 to t equals 4.08. That will be from 15 adding 4.66. Then you need to add this distance traveled. This distance you will need to do is 4.66 minus 2.70. Now we add together. Answer will be 21.62 centimeters. You just need to know that when you're working on this displacement, means the distance from origin.